Namaskar my dear friends. Let us talk about autocorrelation, cross correlation and power spectral density in MATLAB. So what we'll do is we'll try to plot autocorrelation and cross correlation functions as well as their responses. So generally you can see from the theory point of view, like let us say we have two processes, random process which is like let's say x of t and y of t, and you have to find out autocorrelation that will be identified as rxx of tau. That can be written as expectation of x of t into x of t plus tau. Similar to that, if you have to find out cross correlation, then there will be two signal that will be called as rxy of tau, that will be considered as expectation of x of t into y of t plus tau. Similar to that, sometimes rxx of tau is also represented by phi xx of tau. So this is also nothing but autocorrelation functionality only, and it is defined at basically limit tau tends to infinity 1 by tau integration minus tau by 2 to tau by 2, that is one period I am taking and I am dividing it by 1 by tau, and you can see x of t into x of t plus tau dt. So this is how we will be trying to plot in MATLAB. So let's open MATLAB and realize these particular functions. So what we can do is we have our editor page, so we'll just open this particular page, and what we can start with writing is, let us say we'll clear our screen from the command window that I have already told you. We can close all the figures if it is already open anything, and clear all the space variable, workspace variables if it is there already, right? Now let us define a signal x is equal to let's say 1 2 3 4. Okay, so this is the random process signal that is there. Now if you have to find out autocorrelation, then we can do it like this: r of xx is equal to xcore. So xcore is the inbuilt function in MATLAB which will give you the cross correlation or autocorrelation based on the arguments that you are going to give. So since we have only x, so I can give x only. Okay, so x can be given and it will give you the autocorrelation function. So if you just run it and see what is the values that is coming, so I'll just put it autocorrelation plot. Okay, now after saving, you can see we have x is 1 2 3 4, and you can see rxx is column 1 to 4. We have these values, that is 4 11 20 30 and 5 to 7, that is total 7 values are there in autocorrelation function, right? Now what we can do is we can try to plot this particular functions in a figure. So we can do figure. So we have initialized. Let us do a section of two sections in the same figure. So we can use subplot function, subplot, and 2 cross 1 I will do, so that 2 rows 1 column will be there, and I will take first of the section. So first section will be used for the x plot, and I can plot using a stem function because this is a discrete signal, so I can put a stem of x. Okay, now if you run it, you will see we have the figure with the x variable, that is 1 2 3 and 4, right? Similar to that, I'll just collapse this thing so that it gives me little bit of space. All right, now we can do one more thing, is we can plot our rxx variable as well, right? So in that case, what we will do, we will have to subplot 2 comma 1 comma 2, that is second part I will take, so that down it will be shown, right? And you can do a stem of rxx. Okay, so rxx will be plotted. Now the thing is, the difference that I will show it to you, like what will happen. So this is the autocorrelation, and this is the signal. If you want, you can put down your x label, y label, all these things, that will be giving you a good idea about what it is. Okay, so what we can do is we can quickly put it let us say X label. So X label, this will be my like a time axis. All right, and this will be my Y label. So this will be my random variable or random process or signal I can put. Okay, signal amplitude I can put, and similar to that, if you want, you can put title as well. So title will be signal. Okay, similar to that, these three things we can put it for my autocorrelation as well. So in autocorrelation we have time axis, we have autocorrelation amplitude, RXX amplitude, and we'll be writing a title as autocorrelation. All right, so this is how we can plot. If you run, now it will be giving you clear idea about what is the signal and what is its RXX value, that is autocorrelation function. Now the problem is, this may include sometime like let us say it can give you complex functions. So in that case, what we can do is we can always plot the absolute value of this. Okay, so the change that you will do is absolute of RXX. Okay, so in that case it will not give you any problem later on. And if you want for better visibility, you can put grid on. Similar to that, we can put grid on for my signal as well. So this was all about autocorrelation. All right, now if you want cross correlation, what we can do is we will have two signals. Okay, so in two signals, what we can do is, let us say I am going to define a new section and I am going to write down the same thing with one more parameter will be there, which will be, let's say, y. That can be, let us say, 2, 5, 8, 10, or it can have different length as well. So this is how it will be working. Now X core will be what? X comma Y. So this will be giving me cross correlation. So X and Y, if you want, you can plot. Okay, so stem X, and if you can do, let's say, hold on, so it will be plotting Y as well. So let us say X and Y both we have plotted on the same figure. Now this will be my RXX, that will be giving me cross correlation. So what we can do is cross correlation. Okay, so let's do that, and you will see figure 2 that will be coming with X and Y signal on the same figure of first one, and the second figure will be giving me the absolute value of cross correlation function. Okay, okay, I have put here hold, I should put it hold. This is the problem that is showing here, so I should put it hold, right? So I'll just rerun it again, and see, we have blue color as X signal and red color as Y signal, and we have cross correlation function, which is the absolute value plot of this particular X and Y signal, right? So this is how you can plot your cross correlation and autocorrelation on your MATLAB. We will be next seeing the power spectral density plot with frequency as time axis or frequency as X axis. That we'll see in the next session. Thank you so much.